Okay, now we are going to see the problems in cauchy residue theorem. Okay, the first problem, evaluate interval over c z minus 1 divided by z plus 1 whole square into z minus 2 dz, where c is the circle, modulus of z plus a equal to 2 using residue theorem. What is the statement of cauchy residue theorem? Just I will give the hint. Interval over c, f of z dz equal to 2 pi a into sum of the residues at its poles. Okay, residues at its poles. Here I omit at its poles, but the original meaning is 2 pi a into sum of the residues at its poles. Okay, which is lies inside, which is lies inside C, because outside C means the residue becomes 0. Okay. So first we have to identify your poles which are lies inside. After that, find the residue at the poles. Okay, then add the residues and multiply by 2 pi a. Finally you can get the answer. Okay, so first step is I have to consider my f of z. So compare this. Consider my f of z is z minus 1 by z plus 1 whole square z minus 2. Next step, I have to find the poles. So obviously I have to find the singular points. In each and every problem, the singular points is nothing but poles. Okay. So here the singular points are, how do you find the singular points? The singular points are very simple, making denominator equal to 0. Finally you can get the singular point. So singular points are z plus 1 whole square into z minus 2 equal to 0. That means z plus 1 equal to 0, z minus 2 equal to 0, z equal to minus 1, then from this z equal to 2. Therefore, there are two singular points, z equal to minus 1 and z equal to 2. So both are poles, in each and every problem. Our singular points is nothing but poles. Okay. So z equal to 2 is a simple pole, because the power of the bracket is 1, so it's called simple pole. The next one, z equal to minus 1 is a pole of order 2, because the power of the bracket is 2, so is a pole of order 2. Okay. Now I have to find which are lies inside, which are lies outside. That means which poles are lies inside, which poles are lies outside. How do you check it? Very simple way. So consider the circle, modulus of z plus I equal to 2. Substitute the point. Substitute z equal to 2. What do you get? 2 plus I. I have to compare with the 2. So modulus of 2 plus I means square root of 2 square 4 plus 1 square 1. I have to compare with the 2. So root 5 is 2. Squaring on both sides. So this is 5, this is 4. 5 is greater than 4. Therefore, z equal to 2 lies outside the circle. Z equal to 2 lies outside the circle. So z equal to 2 is a simple pole, lies outside C. Okay. Similarly, I can check one more thing. So z equal to minus 1. Substitute z equal to minus 1 here. So minus 1 plus I have to compare with the 2. So find the modulus 1 square plus 1, because minus 1 whole square become 1, 1 square become 1. So root 2 I have to compare with root, so clearly is lesser than 2, or otherwise squaring on both sides 2 is lesser than 4. So z equal to minus 1 is a pole of order 2 lies inside C. Okay. For outside C, the residue is 0. For inside C, I have to apply the residue formula. What is the formula? Just I recall the formula. Suppose z equal to A is a pole of order m, then residue of f of z at z equal to A is, the formula is limit z tends to A 1 by m minus 1 factorial d power m minus 1 by d z power m minus 1 into z minus a whole power m into f of z. This is our formula. Okay. So just apply the formula. So here residue of f of z at z equal to minus 1. Here m is order, so here my order is 2. So my m value is 2, my a value is minus 1. So m value is 2, a value is minus 1. So it's equal to limit z tends to minus 1, 1 by 2 minus 1 factorial, d power 2 minus 1 by d, z power 2 minus 1, then z minus of minus 1, so z plus 1 whole power m. What's my f of z? Z minus 1 by z plus 1 whole square into z minus 2. Just apply the formula, that's all. Okay. So what do you get? This will cancel. Okay. So limit z tends to minus 1. So 2 minus 1 factorial 1, 1 factorial become 1, 1 by 1 become 1. So this is d by dz of z minus 1 by z minus 2. This is nothing but, so limit z tends to minus 1. Just apply u by v. V square v into u dash minus u into v dash. So no need to simplify, directly apply the point. So z equal to minus 1, minus 2, minus 3, and minus 1, minus 1, minus 2, minus 2 minus plus 2, divided by minus 1, minus 2, minus 3 whole square become 9. So this is, what do you get? Here equal to, so minus 3 plus 2 become 1, minus 1 by 9. Okay. So residue at z equal to 0 because z equal to lies outside the circle C. Residue at z equal to minus 1, my answer is minus 1 by 9. Therefore, interval over C, my question, given question. Okay, interval over C, z minus 1 by z plus 1 whole square into z minus 2 into dz, which is equal to 2 pi a into sum of the residue. Here only one residue, so minus 1 by 9. My final answer is minus 2 pi a by 9. This is my final answer. Okay. Once again I recall, consider my f of z. From the f of z I have to identify the singular point. Then I have to classify the singular point, which is a simple word, which is a polar order m. Then I have to verify which one is lies outside, which one is lies inside. After that, lies outside means the residue become 0. Lies inside means I have to find the residue. So just apply the residue formula. Finally, you can get the answer. Finally, my given result is equal to 2 pi into sum of the residue. Here only one residue is there. Finally, 2 pi into minus 1 by 9, which is equal to minus 2 pi I by 9.